So I just want to kind of remind ourselves about the distribution of water in terms of the overall percentage of all the water on Earth. And keep in mind that, again, 97% of all water on Earth is located in the oceans, and less than 1/3% is actually made up of groundwater. You got it's that 1/3% that is actually what basically provides humans almost all of our drinking water in the United States. And a lot of other foreign countries, you know, especially some of the undeveloped countries, they're still relying on surface water as their source of water. Okay, now I do have a very simple question for you. How do we get precipitation to become groundwater? What do you mean by soaks up the water? Okay, so what do we call that process when the water goes from the surface and goes into the ground? It's a part of the water cycle. Not intrusion. Someone done intrusion though. Infiltrate, right? So that's infiltration. What affects the rates of infiltration?
Slow.
Yeah, how compacted our soil is, right? So that's one of the factors. All right, so compacted soils, vegetation. Remember we made a mess over here on the counter? Yeah, so the slope, right? The slope of the land. Not to mention again the type of soil. Not only if it's compacted, but the type of soil. Yeah, all those are going to be things that affect our rates of infiltration. So I just mentioned soil type. Give me an example of how that might affect infiltration. What about sand? It's the other way around. Sand actually allows a lot of water to infiltrate. So if you have sandy soils, you have high infiltration. There's lots of pore spaces with sand. Okay? And they're very irregularly shaped, and they're big in terms of their granules, so you actually have a lot of pore spaces for the water to trickle down through. So sand actually does a really good job at allowing infiltration to take place. Clay, on the other hand, there you go. Yep, you remember the clay when it gets wet, it expands and prevents infiltration. So here you go. So where do we store groundwater, right? Once the water gets into the soils, where does it go? And goes where? You're thinking too big scale. Just in general, where is groundwater stored? Yes, but where in the ground? Oh, not likely. Can be in caves. That would be surface water. Yeah, it's stored in the soil. So it's stored in the pore spaces of the soil. And we call that an aquifer. So we think about an aquifer, all it is a layer of soil that is completely saturated with water, which means that every open, available pore space is filled with water. Well, more like a sponge. More like a sponge. In fact, I won't challenge you guys to this, but if you want to do it from home, go for it. Take a sponge and run it underneath the faucet, get nice and full, right? And it'll expand. So the airspace is pushing in and out. Water is taking up the space, therefore it expands. You can actually suck the water out of the sponge with just a straw. With a straw down on the surface of the sponge, you can actually suck some of that water out. It sounds really gross, but you know what the sad thing is? How many of you guys have wells at home? Okay? How many of you guys do? Probably not in the city garden. That's exactly what the well does. Is it goes down and drills down into the supersaturated layer, and then just like the straw on the sponge, it sucks the water out of that layer. Anna?
Yeah, my hermit crab drinks out of the sponge. That's what they told us to give it.
Alright, now another one that I want to point out to you guys here, which one of these has more available space? The well sorted. Again, we know their well circuits are all the same size. These are not sorted at all. So your well sorted actually has more space available than a poorly sorted area. So again, that's kind of one of those key things when we look at the soil. You know, either is it well sorted or is it poorly sorted? Yep. Sometimes that could be really easy to find out. And this kind of leads us into what we're talking about, the water table. When we really think about the water table, right, this whole layer right here, that is our zone of saturation. And the zone of saturation, another word of that, is the aquifer. Remember, the aquifer is that saturated layer. And that's where all your groundwater is stored. And it's stored in these little pore spaces, all inside this layer. And then that upper boundary is your water table. So right here is the water table. And then above the water table is the zone of aeration. Okay, what does it mean to aerate? Yeah, literally, to put air inside. So when we talk about zone of aeration, it's basically air filling up the pore spaces rather than water. Okay, and then of course above that we have our topsoils. So zone of saturation is that layer of soils where it's completely saturated with water. And then the water table is the very top layer of that. So does that kind of help you guys get a visual what a water table is when we talk about aquifers? And when we talk about aquifers, we're not talking about a small thing. Aquifers tend to be very large in the regions. And then in fact, there is an aquifer that basically takes up the entire Midwest, all the way from the bottom of the Rockies, all the way out to the Appalachians. The whole middle section of the United States is one giant aquifer. And it basically is what is used for farming. The problem with aquifers is it takes thousands of years to recharge. And then that's a phrase I want to make sure we talk about today, recharge. Just like recharging your phone, you plug it in and it increases the battery life, right? And when we think about the water table and the aquifers, a recharge is precipitation coming in, infiltrating the ground, and then reaching that zone of saturation again, and basically it's replacing the water that's been used. The problem is with a lot of our aquifers in the United States is that we're using more water than what's being recharged. Keep in mind that basically groundwater moves about a mile every 100 years. So it's a very slow moving, very slow to recharge. So when we think about wasting water, this is one of the things when we talk about when we think about conserving. This is why it's important to conserve our water use, because it takes a very long time to replenish that natural resource. A couple of things that's worth mentioning. Groundwater will move in the same direction as the slope. So if I have a hill, my groundwater is going to move in the same direction. But it runs parallel to the slope. And it depends on the permeability. Yeah, that's kind of a big word there, permeability. What does that mean? What does it mean to be permeable?
How well water flows?
No? What do you mean by that? Because it definitely affects how well the water flows. But what does permeability mean? Has ever heard of that permeable layer? And what does that mean? You guys heard of porosity before? Talk about that when we talk about rocks. Porosity. What does that mean? What does it mean to be porous?
I mean, pores it has.
Gosh, you made it. Okay, porous means you're full of holes. Okay, so porosity is the amount of holes that something has. Now, if you have lots of holes, that means lots of stuff can get inside, right?
Yeah.
That's permeable. When a substance can flow through and into another substance, that's called permeable. Your skin is impermeable. Porous, but not porous. And your skin is designed to keep the water out of the inside of your body. Okay, so it's an impermeable layer. But when we think about rocks, when we think about sandstone, sandstone is a perfect example where there's lots of pore spaces. Therefore, it's very porous. It has high porosity, which means that water can easily get inside the sandstone, and therefore, sandstone is permeable. It has a high level of permeability. So again, permeable means to be infiltrated. And when we see this level of permeability on a large scale, is what we call the aquifer. Now, a couple of things I want to mention here is, the thing about this is we have aquifers, which are large layers. Right, so here's my ground. Actually, let's put the ground above that. And then I'm going to have these alternating layers of soil. And let's say that this is my water table right here. So here's my supersaturated soil. Well, that means that this layer right here is permeable. Because the water was able to percolate downward and get in. But notice that I'm not having water down here in this layer. What does that tell you? It's not permeable. So which means you might have something like clay that prevents the water from being able to go down further into the ground. So there are lots of things like this. So if you have a clay layer, shale and slate are examples of rock layers and soil layers that will prevent water from being able to get into them or flow through them. They just don't have a lot of pore spaces. Okay, and we call those aquicludes. So again, aquiclude is a barrier to groundwater. It prevents the groundwater from moving. All right, I'm going to end it here.